Want to learn about homeostasis? Well, you've clicked on the right episode. Welcome to the Netflix original series, The Homeostasis Show. In this episode, we will be covering 4 major concepts including what is homeostasis, the maintenance of homeostasis, a negative feedback loop, and the regulation of blood glucose levels. First, it is important to understand the meaning of homeostasis. Homeo meaning sameness, and stasis meaning standing still, is the maintenance of relatively stable conditions in the body's internal environment. It occurs because of the ceaseless interplay of the body's many regulatory systems. In response to changing conditions, the body's parameters can shift among points in a narrow range that is compatible with maintaining life. For example, the level of glucose in blood normally stays between 70 and 110 milligrams of glucose per 100 milliliters of blood. All cells and organs participate in some way to keep the internal environment of the body within normal limits, and the autonomic nervous system is dedicated to the whole process. We must prevent extremes in temperature, pH, ion concentration, and just about everything else or we die. For example, if our body's temperature is too high or too low, it doesn't function properly and may lead to death. Homeostasis is a dynamic process rather than static because it is constantly adjusting to the changes that the body's systems encounter. Some examples of external perturbations in homeostasis would be instances such as increased or decreased environmental temperatures. For instance, if you go outside and it's 26 degrees Celsius, in order to maintain a core body temperature of 37 degrees Celsius, your body will sweat to get rid of excess heat. It will also dilate the blood vessels in the skin to help increase sweating. Some examples of internal perturbations in homeostasis include things like sugar in the food we eat and the byproducts of metabolism. We can't have too much sugar in our blood because this causes damage to blood vessels and eventually fine nerves in our fingers and toes, and we start losing feelings. We also can't have too little sugar in the blood because the central nervous system runs almost exclusively on glucose, so you have to have some there all the time. This is why it is so important to homeostatically regulate things like blood glucose levels, and the process by which we do so will be later explored in this episode. Moving on to the maintenance of homeostasis, there are 2 means by which we can maintain homeostasis. One way to maintain homeostasis is with positive feedback, while the other and much more common method is with negative feedback. So there are components to a feedback system which we will now be discussing. Firstly, we have the variable, which is what is being regulated. Next, we have a detector or receptor to detect change in the variable from its set point. The stimulus is the movement of the system away from its set point. Next is a control center to figure out what to do when the stimulus is detected. Lastly, an effector to move the variable back to normal. This effector deprives the system of the stimulus and terminates the feedback loop.
So what we're going to be focusing on in this episode is a negative feedback system. A negative feedback system reverses a change in a controlled condition. So as you can see by this diagram, first we have the alteration of the variable known as the stimulus. The detector is then going to detect this change in the variable and tell the control center about it. So then the control center, which initiates an appropriate response to this change, signals this message to the effector, which will cause a change in the variable to reinstate balance. Homeostasis. The first example of a negative feedback loop that we'll be discussing is what your body does to maintain homeostasis when your blood glucose levels are too high, a condition known as hyperglycemia. Hyper means high, blood comes from glucose, and emia refers to something that's in your blood. Therefore, a condition in which your blood glucose levels are higher than normal. Your normal blood glucose is about 4.5 millimoles per liter. So say you drink a very sugary drink, like Fanta. This will cause an increase in your blood glucose levels, acting as the stimulus. The beta cells in the pancreas then detect this increase in blood glucose and are going to decide what to do. So they act as both the detector and the control center. The detector by detecting this increase in blood glucose levels, and the control center by determining an appropriate response. So in response to this increase in blood glucose levels, the beta cells in the pancreas will release insulin to talk to the effector tissues. So the insulin is a signal from your pancreatic beta cells talking to your effectors. So your effectors would be your fat, your adipose, your skeletal muscles, and your liver. They all have receptors for insulin, and when insulin's there, they start pulling in glucose from your bloodstream and putting it inside your cell. So your fat turns the glucose into fatty acids and eventually triglycerides where it's stored away. Your skeletal muscle stores it for later use, like when you're sprinting to the subway before the door closes, you'll use that glucose later. And then lastly, your liver converts this glucose into glycogen and stores it in between meals. Your liver stores it as glycogen and not glucose because glucose itself will pull a lot of water into your liver and cause it to balloon up. So, in all, the response is that your blood glucose levels would decrease, bringing everything back to normal. Homeostasis. So, what would happen if you had hypoglycemia? Hypo means there's less of something, glyc comes from glucose, and emia refers to something that's in your blood. Therefore, hypoglycemia is a condition where your blood glucose levels are lower than normal. So, in this scenario, alpha cells in the pancreas would act as the detector by detecting the decrease in blood glucose levels, and they also act as the control center by determining what to do. In this case, the alpha cells in the pancreas will release glucagon, which is a hormone to talk to your effector, which is, in this case, the liver. So then the liver breaks down the glycogen into glucose, a process known as glycogenolysis. Lysis means to break down, and glycogen is what it's breaking down. So this glucose will be released into the blood so that the brain, the heart, and the lungs can use this energy to keep going. So what's the response to this? This causes the blood glucose levels to rise, bringing everything back to normal. Homeostasis.
And that concludes this episode about homeostasis, always working in the background to maintain internal conditions, like a thermostat. Get it? Because when the temperature on a winter day drops below the level you've set, the thermostat sends an electrical signal that turns the heater on? No? Okay, I thought it was a little funny. Cue the end credits.
Homeostasis, organs made to work. Signals, brain will talk to you for internal balance. Your body in control keeps your body stable. Brain sending signals, changes in environment anywhere you want. Keeps internal balance and never letting go. And never letting go. Temperature's high, thermoregulation. Animals cannot survive if they're too hot or too cold. Skin and blood make it right, yeah, you already know.